In this video, I want to talk about different types of probability sampling. Remember that probability samples are the ones where it's basically left up to chance as far as who is going to be part of your sample. It is based on probability or based on chance. And remember that these are the types of samples that do allow you to make generalizations, that allow you to make conclusions about the broader population based on what you have observed or measured within your particular sample. So to kind of illustrate what that looks like, you have a population that you are interested in. So if, for example, you're studying something about social media, your population might be all social media users, but you're not able to actually survey all social media users. So you use some kind of a sampling strategy to figure out which particular social media users are going to be included in your sample. And then you administer your survey or whatever research method it is to that sample. And then if it is a probability sample, at the end, after you've tabulated your results, you can make an inference. You can make a generalization about the overall population based on what you have found to be true in your sample. So let's talk about three particular types of probability samples. And there are other types as well, but I want you to understand these three main types: simple random, systematic random, and stratified. So let's start with the first of those, simple random sampling. Now, the term simple random is a little bit of a misnomer because it's actually kind of complicated to do a simple random sample. There's not very much that's simple about it. But a simple random sample is kind of like drawing people's names randomly from a hat. In communication research, we don't typically draw names from a hat, but the idea is the same. You put all the names together and then you select a certain number of them randomly. And that means everybody should have an equal chance of being selected for your survey. So in communication research, rather than using a hat, we usually start with a list of all of the people in our population. And we assign a number to each one of those people, starting with 1 and then just giving everybody a number. And then to draw the sample, we use some sort of a random number generator, which will spit out, 10 or 20 or 50 or 1,000 random numbers. And whoever matches up with those numbers, those are the people that we select for our sample. Now, let me just say a couple of things here about random numbers. You may think that you can just come up with random numbers on your own, 2, 51, 364, 5,297. But we know that human beings never behave randomly. There is always a pattern, a rhythm to our behavior. So you can't trust yourself to generate random numbers. You actually need to use either a random numbers table. There is a random numbers table in the back of your textbook, or a random number generator. There are sites on the web like randomizer.org, and there are apps for your phone that will generate random numbers for you. So whoever corresponds with those random numbers, those are the people who you give your survey to, or those are the people you interview or whatever. One other bit of terminology here, the list of all of the people or items in your population, there is a name for that. That is called your sampling frame. Okay. So if you were doing a survey of Shippensburg University students, and you have a master list of every student at the university, that list would be your sampling frame. And then you would use the random number generator to select maybe 100 students or 500 students or whatever for your sample. That is simple random sampling. The next type is systematic random. Okay. Now, the word systematic implies that there is some kind of a system, a pattern, a rhythm to it. And that is certainly true with systematic random sampling. Systematic random sampling can be a good alternative in those situations where you cannot obtain a master list of everyone in the population. So systematic random sampling involves sampling every nth person beginning at a random starting point, okay? So in other words, you are studying every 10th person, or every 20th person, or every 100th person, beginning at a random starting point. And that second part is crucial, because if you just automatically start with person number 1 every time, then person number 1 would always be selected for the sample, and it would no longer be random. So you start at a random point, and then from that point forward, you just select every nth person. And whatever that value of n is, that is your sampling interval. So if you sample every 10th person, your sampling interval is 10. Now, this can be a very effective form of probability sampling, but there are certain situations where it can be a problem. And that problem usually involves something called periodicity. What the heck is periodicity? Okay, periodicity is when there is a pattern in your population that matches your sampling interval, and as a result, you end up with a very biased sample. Let me give you an example of this. Let's say that instead of doing a sample of people, you are studying a sample of newspapers. And let's be even more specific and say a sample of print copies of the Philadelphia Inquirer from the year 2022. I know that these days, most people aren't reading the print versions of newspapers, but let's just run with this for a second. You want to find out how much space the Philadelphia Inquirer in 2022 devoted to news versus sports versus business versus features, etc. So you actually round up a copy of the print newspaper from every single day in 2022. You have a stack of 365 Philadelphia Inquirers, stretching from January 1st of 2022 all the way to December 31st of 22. 365 of them. And you say, oh my gosh, I can't possibly study all 365 of these. I'm just going to study a sample. And I'm going to use systematic random sampling. I am going to study every 7th newspaper. So you begin at a random starting point. And let's say that random starting point just happens to be a particular Sunday. And you study that newspaper. How much space did they devote to sports versus news versus business versus features? And then you go 1, 2, 3, 4, 5, 6, 7 in your stack of newspapers arranged by date, and you grab that paper. And then you go 1, 2, 3, 4, 5, 6, 7, and you grab that paper. And you keep grabbing every 7th paper. And those are the papers you focus on. Hopefully you can see where this poses a problem, right? Because there also happen to be 7 days in a week. So if the first newspaper you grabbed was a Sunday newspaper, and then you go 1, 2, 3, 4, 5, 6, 7, the next paper would also be a Sunday newspaper. In fact, every paper in your sample would end up being a Sunday newspaper. Is that a problem? Sure, that's a problem, because we know that Sunday newspapers tend to be much larger and very different from papers the rest of the days of the week. On weekends, there's not as much breaking news going on, but there's often a lot of sports going on the weekends. So when you studied only Sunday newspapers, you would end up with a very biased sample that's not reflective or representative of the overall population. So that's something to watch out for. If there is that pattern in your population, systematic random may not be the best option. Let's talk about one more type of probability sampling, and that is stratified sampling. When you do a simple random sample, like drawing names out of a hat, in theory, you should end up with a representative sample. But in reality, you may end up with certain subgroups of the population being overrepresented and certain subgroups being underrepresented. And depending on your research topic, that could create some big problems. Let's say you were doing a survey where you were trying to get a sense of how different religious groups on campus at SHIP, react to something, some kind of a survey where you're trying to compare different religious groups. If you just did a simple random sample where you just drew 100 students at random, you may end up with a sample that doesn't include a single Muslim student, or doesn't include a single Jewish student, or doesn't include a single student who is non-religious. And that could be a problem if you want to make sure that all of those different groups are represented. So in a stratified sample, what you do, it's actually a two-step process. You begin by dividing your population into strata. So maybe you divide your population into all Christian students and all Jewish students and all Muslim students. And I realize that that might be very difficult to do for this particular example, because you probably don't know what their religious background is, okay? So this may not be the best example, but you get the idea. You're dividing your population into strata. Better example might be, freshmen versus sophomores versus juniors versus seniors. You're dividing your population into those strata or subcategories, and then, this is the second step, you then randomly sample within each of those strata. So you select a certain number of freshmen, certain number of sophomores, certain number of juniors, certain number of seniors. So it becomes a two-step process. First, you divide the population into those subgroups, and then you randomly sample within each of those subgroups. And the idea here is that a stratified sample should guarantee that each of those subgroups are accurately represented in the sample, whatever those subgroups might happen to be, whether it's academic standing or it's religion or it's gender or age or income or whatever. So that is a third form of probability sampling. So you got your simple random, systematic random, and stratified, the three main categories of probability samples.